So let us now solve the second application, electric field due to conducting sheet. In the previous it was a one dimension, now we have surface two dimension given. If it is a surface, it means instead of linear charge density, surface charge density is given to you. Surface charge density is given to you. Let us draw a Gaussian surface again in the form of cylinder. Let us draw a Gaussian surface in the form of cylinder. You know that in previous we cut some of the surfaces again in this S1, S2, S3. I call this S1, S2 and this one is S3. The normal in this side, the normal is in this side, the normal in this side. Now this positive charge lying on its surface, this positive charge lying on its surface. If it is lying on its surface, it means the electric field in this side, again the electric field in this side and electric field in this side. Now problem ये देखो बच्चे, what is the angle? Now in this case the angle will be 90. If it is 90, then cos 90 will be 0. But in this case theta is 0, in this case also theta is 0. It means instead of 1 there is 2 contribution given for the electric flux, but in previous it was only 1. No problem. Let us start. Now sigma is given to, sigma is charge per unit area. What will be charge on the given Gaussian surface? Sigma into area. Now according to Gauss law, it should be net charge divided by epsilon naught, but charge I calculate sigma into A by epsilon naught. Now this is given by Gauss's law. हम सॉल्व करते हैं इसको. If I solve, I will get that it will be E vector dot ds vector. It means E. Okay, now I split in two parts. One is S1 EDS, second is S3 EDS. E2 का तो जीरो हो गया contribution, cos जीरो गया था. ठीक. Take E outside, inside I get SDS, second I get S3 DS. So what is ds? ds, it is the area of Gaussian surface. Area of Gaussian surface. Got it? What we do? Let us assume that its area is A. Later on I will substitute its value, whatever the value. Why I am taking A? Because in equation number 2 I am taking A is the area of Gaussian surface. So that includes the charge Q. So it will be A plus A. कितना A हो गया? 2A हो गया. This is equation number 3. This is the flux that we calculated by using the formula E dot ds, but this is the flux which is given by the Gauss's law by substituting sigma A by epsilon naught. Okay, if you compare 2 and 3, if you compare 2 and 3, what we get? If we compare 2 and 3, we get, हाँ जी बच्चे, we get E into 2A is equal to sigma A by epsilon naught. A बच्चे cancel out, so E will be equal to sigma by 2 epsilon naught. What is E? Once again, E is the electric field produced by this sheet. Sigma is the surface charge density. Epsilon naught, you know that it is a constant absolute permittivity. Now question come, draw the electric field variation with the distance. This side is E, this side is R. What type of graph you get? Straight line. Why straight line? Because you can see it is independent of R. There is no term of R. That is why we are drawing a straight line. Clear this one? Its application, its third application, or it is similar to this, is that instead of one sheet, now you are taking two sheets. But its sigma, its surface charge is sigma 1, it is sigma 2, both is positive, I suppose. Now I want to find the electric field due to these two. Our formula clear है, वही पीछे वाला sigma by 2 epsilon naught, but for this sigma 1, for this with sigma 2. So what we did, we assume we divided this into three region. First region, second region, third region. We assume that this is I'm taking as origin. So this side will be positive. If I move to this side, then it will be negative. It means the electric field at this point due to this will be minus first ka minus second ka. But if I go to this side for this it will be plus, even इसका opposite है तो minus. If I move to this side both it will be plus. फिर से सुनो, इलेक्ट्रिक फील्ड दिस साइड विल बी पॉजिटिव बट इफ आई मूव टू दिस साइड देन इट विल बी नेगेटिव. अगर मैं इस रीजन में दोनों के ऑपोजिट इस साइड आ गया away away from the electric line, that will be negative. But if I'm this region positive, both of same magnitude, but this will be negative, this will be positive. But if I get inside, for this it will be positive, this will be negative. It means in first region electric field will be minus sigma 1 by 2 epsilon naught minus sigma 2 by 2 epsilon naught. In second region it will be sigma 1 by 2 epsilon naught minus sigma 2 by 2 epsilon naught. And in third region sigma 1 by 2 epsilon naught plus sigma 2 by 2 epsilon naught. Clear? This is the end of this article. There is a special case. Special case is what is the special case? That instead of we said that there is one is positive, another is again positive. But what I did this positive, but this as a negative. It means sigma 1 I am taking plus sigma 2 I am taking minus sigma. Very important. This I will use in capacitor also. One is plus sigma, another is minus sigma. Now what will be electric flux? बच्चे देखना बड़ा इजी है. अभी इसमें हमने कहा था इसकी इलेक्ट्रिक फील्ड जो इस पे होगी दोनों की नेगेटिव होगी, बट एक नेगेटिव है दूसरा पॉजिटिव. तो यहाँ पे क्या आएगी? जीरो. यहाँ पे भी क्या आएगी? जीरो. यहाँ पे कितनी आएगी? सिग्मा बाय. मैं प्रूव भी कर सकता हूँ. मैंने अभी कहा था बच्चे E1 का फॉर्मूला था माइनस सिग्मा 1 बाय 2 एप्सिलॉन नॉट माइनस सिग्मा 2 बाय. But in my question, sigma 1 is plus sigma 2 is minus sigma. If you put, you get answer comes out to be 0. In the similar way, in second region, it was sigma 1 by 2 epsilon naught minus sigma by 2. If you put this value, you get sigma by epsilon naught. So this is the application, third application, but it is a continuation of the second one. That electric field between two parallel conducting sheet is given by this formula, and this is very useful in my next chapter also in capacitor, where I will write the electric field between two sheets is given by sigma epsilon naught. Thank you very much.